Perfect. All right. So I'll open that guy, and then I think we should open the other guy as well. I'll add it. So the problem is that the second one we will fill all remaining time, which is why we should probably start with the shorter one here. So we can do this in 10 minutes. You want to walk us through it?
Yeah. Okay, so the proposed API change is to add a new method called isPathFullyQualified. That's a little bit more clear than what isPathRooted is doing. So right now,
sorry, Emo, could I ask you to share your screen or whatever we need to do?
Probably do that. That was a good idea.
Are you using the room mic today instead of your laptop mic?
Yes, we're using the room mic, so we actually have the chance hearing what's going on. Oh, let's check window. Here we go.
Okay. So right now, isPathRooted returns whether or not the specified path contains a root, and the assumption is that if isPathRooted returns true, then the path is not relative. And for most cases, this is true, but there's one case where if you have a directory with the root of the directory like C:, and then the path without a backslash, then isPathRooted will return true, but this path is actually relative. And so the assumption that isPathRooted returning true, meaning it's not relative, is false. And so the suggestion is to have a new method isPathFullyQualified that would tell you whether changing the current directory will change the path. And so for isPathFullyQualified, C:, backslash, it would return false. And this would be a little bit more clear than what isPathRooted is currently doing. And the good thing is that this is already written as an internal API, so we would just have to make it public.
I see. So
can I ask, is there the fact that isPathRooted returns true in this case, that's desired behavior, or that's an artifact of the past that we would fix if we could, or?
Can you turn it down a bit?
Yeah, it's desired behavior because it does contain like the name of a root directory, but I think it's just that a common usage is to use isPathRooted to determine whether or not the path is relative. And so this is one of the cases where it is relative.
To put it a different way, would anyone want to call isPathRooted after we add isPathFullyQualified?
Oh, yeah, well.
I'm wondering if we actually need a new method or whether we could just fix isPathRooted.
Well, I think based on
I would expect it to break a ton of apps if we change it. Because if people are actually looking at it as rooted, which doesn't mean that it doesn't include the current directory. Rooted just means it's rooted to a device, is what it's supposed to mean, or what it does mean at the moment.
I think the problem is that there's
actually relying on that behavior, then it would break them.
Yeah, I mean, the question is, what do we do for like C:, foo.txt, right?
C:, MyDir is explicitly in our things of a list of things it returns true for on MSDN.
Sorry, say again?
It's in the documentation.
Returns true for that.
Yeah, that's what I mean. So basically, so the question is, let me actually.
So the more specific problem here is things that begin with a backslash.
Right. This is basically a Windows-only concept. Nobody else has that.
Yes.
If we want to support that, then I think we need two different APIs, because otherwise you're like, okay, the path is not rooted, or except it has a drive on it, right? So like that seems very weird. But I mean, that's the behavior that we have on Windows. So we could add a new API, like, has drive root or something. But then the question is, well, I guess is path rooted is full with the
the statement true if the current directory does not affect the evaluation of the path, the meaning of the path, is well defined on all operating systems.
Yes.
What does isPathRooted do on Unix right now for that?
Well, they don't have it included,
right? So it's oblivious.
Because on rooted, this is the way it works on Linux. Is like it's basically starting with a slash, right? Anything else is relative, and then this is where you go from the device root. So
what about tilde?
It's basically
tilde isn't recognized in our Unix code.
Tilde is a shell-specific character.
So
the shell expands that. That's
can you hear me?
Yeah.
Yes.
All right. So the real issue we're looking at here is the one that starts with a directory separator. So if it starts with a directory separator, which we just looked at the Unix one, but on the Windows side, that's considered rooted, but it's also relative.
Wait, you're saying that that path.isRooted returns true on Windows for /foo?
Yep. And that's always been the case. And because of that, right, it's really hard to change. So
and we could fix it and then make it quirk, but quirking is app context, right? So if a library relies on it, you can't change your applications, right?
Precisely.
Well, I would also question whether that's desired behavior.
Well, I'm wondering, like, what does anyone use path.isRooted for if it returns true when it begins with a / on Windows?
Yeah, that's what I'm wondering.
I mean, I've certainly written code like this in the past. I wrote my own make relative path function, which we also now have, but we didn't used to have. And I basically had code like, is rooted, like take it as is, otherwise make relative. And if it's not rooted, make it relative, basically. So that all of that code was kind of like busted in the past.
What about, did you consider an overload of isRooted? Like we added string split with string split options. Remember that? Like,
yeah,
we could have something like isRooted up. I mean, I think this is lame, but I'm just wondering if we could have an overload of isRooted, right? Because I'm thinking of path dot, and now I don't know which one to pick. Whereas if I had an overload, then I know I'm going to pick is path rooted and then try and figure out what to do.
What would the options be?
Boolean. Do you really mean it?
Yeah.
That's why I say options, because I thought that was pretty lame as well.
So the current definition of is path rooted is, does this path string contain a root? It's not, is this thing relative? Everybody takes it as that, but it's not the way it's defined. And it's an unfortunate thing.
Yeah. The first real caller, or searching on GitHub, if people are using it, like if it's rooted, return it. Otherwise, do path.combine. So they seem to all be using it for is or not is relative.
If it's not fully qualified, is it always correct to do path combine with some root to make it fully qualified?
No. Because that's C: case that you're talking about.
So they're getting it wrong again.
Because if you combine current working directory with C:foo.txt, do we not give you a thing on the C drive?
I believe we err.
Oh, okay. Well, that's fine.
Combine fails with that one.
So I still don't know why anyone would do that, because if you wanted a full path, you just do get full path on it, unless you think that's slow, which it is, and then you might do is rooted, and then do get full path.
Yeah, and that's the real usage for these things, is to optimize out of like doing full normalization.
To Jeremy's question, I don't think we error out. I think, if I remember correctly, path.combine checks is rooted on the second, like if you give it foo and C:text, yeah. I think it checks is rooted on the second argument, and if it's rooted, it just gives you back the second argument.
Yeah, I think that's right. So that code is not.
So is there any case where we would want is path rooted to return true for C:(A)?
You're correct.
So here's the other problem, is that like is path rooted actually returns false for C:. It only returns true for C:\.
It's really broken. Well, this is from 1.0, right? And someone just wrote this.
It's been around since forever.
Yeah. So I still haven't heard a single case where it's valid to call is path rooted, where that would remain the sensible thing to do.
Well, I mean, I guess one of the niceties about this thing is that I think is path rooted is, yes, it's an API we have for a long time, but I don't think it matches what people would look for anyways. So I think generally speaking, like people think of, get full path and is fully qualified as kind of like things that are related. Is path rooted is only something that you find after browsing that and like not seeing anything else, and then you give it a chance, right? So I think generally speaking, like it's not that the best name's already taken. I would argue that.
Would it help if we called it path is full path?
Or is relative path, which is most people think of in that terms.
Yeah, like I think Jeremy considered that, but Jeremy found an issue where that's not what you want it to be. Like relative and fully qualified are two different things.
So Stephanie, did you consider calling a path as full path? Does that make sense? Or
Is full path?
Yeah, because
I think that would be confusing with get full path, because to say that it's fully qualified does not mean that it doesn't have relative segments in it.
So I think when you do get full path, you don't care. I mean, I've never cared about relative segments. To me, get full path just mean, well, no, you're right. Sometimes you use it to canonicalize, and sometimes you want it to make it.
Because that would be a normalized full path.
People want to say whether or not they need to call get full path, right? That's basically
right. Sometimes you call get full path to normalize.
Sometimes you just append a directory.
Common directory independent.
They seem to want to know if they need to call path.combine, except since we call this method from path.combine, they should apparently just really always call path.combine.
That's right. They should. Yeah, that's right.
But
what a mess.
Yeah, it's unfortunate.
So what's the distinction? Like someone said that this isn't the same as not relative. So what is relative?
Relative. If you look at the link that's on the thing, it goes to the MSDN documentation. But relative basically means that some part of the path is relative, not that it has current working directory. So the documentation, she has a link on documentation there.
Okay.
So there's fully qualified versus relative paths.
So is fully qualified would return false if you had a full path that had ... in it?
No, is fully qualified would return true. Fully qualified means that it does not, it will not change if you change the current working directory. Is essentially what it means.
Path is a special case of fully qualified path.
So changing the current working directory is not going to change ... that are embedded. If it starts with ... yeah, that's doesn't have a root, and it's not that special case of drive relative, which they show there too.
So you're saying get full path will not evaluate ... in the middle?
Get full path does.
Okay.
It wipes them out. So get full path is actually, it normalizes the path completely.
Yeah, that's what I thought. Okay.
People are also asking, incidentally, for something that removes that normalizes the directory, the relative directory segments, but doesn't like put the doesn't like fully resolve them, right? Doesn't add the current working directory in, which we have that as well. We just don't have it exposed.
So basically, I think is path rooted is something we should just at some point provide guidance for the people like you probably don't want to call this API unless you have a really super narrow use case that I can't even come up with. And then the other one is basically one really is fully qualified.
Yep.
I think that seems reasonable to me. Are there any concerns with that proposal?
That's a terrible example. C:\.\/tip.txt.
Hmm?
Out of your screen. That is horrible.
Oh, there are examples.
This one. Yeah, but it completely makes sense, right? Once you understand what C:\.\/ means.
Yes, use the current the current context path off of C:\.
Right.
Back up a directory and then open a file. Yeah. You have no idea of knowing what the context
have you done that C:\foo and it's foo?
You can read the secret environment variable that you're not supposed to know about to know. Point to.
So we mentioned that if we just fixed his path rooted, it would break people, would it?
Yeah. I mean, DDCC would say it will break someone. Therefore,
you have a quirk.
Answers based on paths that absolutely will break.
Yeah, you quirk it and everything else, but would it be impossible for someone to opt into the quirk because they lightly break?
Well, the way quirking would usually work is that you would say if you're compiled against, let's say 4.7.2, which is the next version of the framework, you get the new behavior.
So I guess by quirk I mean whatever we do in .NET Core, which is like app flags or something, right?
Yeah, that's what I mean. Like usually goes for what was the app compiled for. If the app is compiled for an older version, you get the old behavior.
I see.
And if you retarget to the current or later version.
I mean, I agree that it's probably unacceptable breaking change. I'm just having trouble thinking what someone would be doing.
So what somebody could inadvertently be looking at, and I mean, it's their input data that not have it fully if they fully understand their input data, or maybe they don't understand their input data, but like all the cases that they have are coming in as either starting with a directory separator or not, right? That API would behave in a particular way, right?
The problem would be if somebody right now will return true for C::. Temp, I think, because it has a colon in the second position.
It needs to have like the current implementation, it needs to have a directory separator at the end of the colon.
So we'll return false for this one?
Yes.
Oh.
And that's sort of an orthogonal problem.
Okay, because the problem would be for something that we're returning true for right now, if somebody doesn't call path.combine to resolve it, and their code happens to work with a relative load, and then we change the behavior, and then now they start calling path.combine, and that evaluates to a different directory than whatever was going to have happened. Because the place that they do the check and the place that they do the evaluation could have changed the working directory in the meantime.
Yeah. I mean, clearly this case is like that because it's producing different results. It's going to break somebody.
Right.
I'm just trying to think of a sensible case.
Well,
but I know we don't want to break nonsensical cases. So.
Right.
Well, the problem of sensical and nonsensical is not so much whether it's sensical versus nonsensical. It's more about, do you change a condition of the program? So let's say the previous one returned a different error than the new one does, or it was a no-op, and now it becomes an issue, right? I mean, you could imagine, for example, that with the old call path, the file didn't resolve to an existing file on disk, or the program handled that case and continued. Now you're changing it to a file that actually does exist on disk, and now the program tries to parse the file, but the file is invalid and crashes. Right? These are always the cases where, given enough customers, the firewall will form with your hard drive. Right?
And URIs, file : /
You're a naughty boy. If you do that. That would be my response. Don't pass it your else. This is not for your own.
I like the name of the new thing because it at least, I don't know if it's POSIX terminology, but at least it matches the terminology that Windows has put up here.
Yeah.
And what about / and all that?
This handles it.
Okay.
The current implementation handles that. So it handles all known path formats. The code is actually relatively simple. There's a link to that as well in the thing. Once you know all the rules for the Windows paths, the check is pretty much simply looking for the special drive : thing, and also looking for 2 double backslashes.
Is UNC fully qualified?
Yes, because you cannot have a relative path for a UNC.
So double front slash is still fully qualified on Unix. Okay.
Double front slashes and any valid path are always.
What about leading white space? I bet is path rooted doesn't trim it, right?
And no, so yeah, and resolving, it's one of the many quirks of the Win32 path resolving. While it will normalize separators, right, to combine them and collapse them, it doesn't do it for the first 2. Specifically because of UNCs, right? So.
To be fair, if you took a thing that started with a space and we say, no, it's not fully qualified, and you run it through path.combine, it will give you a different answer. It will give you the trim value of whatever you gave it.
So you guys are realizing what a giant mess.
We've been rolling back the trimming stuff and leaving it to Windows to do it, which Windows won't trim a preceding space, but.
And finally, Unix, this is always well defined.
Unix, it's always just doesn't have the directory separator in the beginning.
So is it fair to say that on Unix is path rooted and is fully qualified are effectively the same?
On Unix, they are. Because there is only one root. That's kind of the fundamental problem here. Is that Windows there are multiple roots. There are n numbers, not even 26, right?
But at least in this, I mean, the problem is effectively the way Windows works is that there's an actual absolute root, which is effectively the \\/ question mark thingy, right? Which is the actual way NTFS thinks about things, and then there is that which is drive specific.
Don't get Jeremy started because he'll tell you that, but it's far more complicated than that.
It is more complicated than that. I won't start.
It's actually really interesting, but we'll never get to it.
Yes.
So I have no objections to.
Okay, so then we leave that as is, as like improve as proposed.
Good with me.
And we just need to get the documentation to be updated to clarify between the two when you want to use them.
Yeah,
and update the documentation to say don't use this path.
Yeah, if we don't think there's any real case that people would want the current one, then we should add it to Emo's tool of functions you should never call.
And
I think I should do that as, I mean, yeah, I still think it's conceivable that people have some situations where they might be using it, or want to use it, but we should encourage them not to, I mean, only use it if you really know what you're doing.
Do we have any code that calls is path rooted in the IO code other than path combined?
Hold on.
Presumably we'd like path combined to change to is fully qualified, but we can't change that either.
Oh no, that actually needs rooted. Let's see, come on.
It is rooted, but it's going to get it wrong for C:/. Okay.
It's used all over the place, but in...
We can't change.
I think I was specifically wrong. I was wrong about combine. It looks like combine's literally just checking for directory separators.
No, it like combine calls combine, at least in NetFX, combine calls combine no checks, which checks both.
Oh, it does check path rooted. Okay, I was right the first time. Yeah.
Where the heck?
Yeah.
It doesn't look like we call it very often. A lot of internal code calls it, for sure.
Looks like there are a bunch of asserts that use this path rooted.
Yeah, and so for NetFX, if we would want to switch that to fully qualified for correctness, that'll probably require a quirk. That's DDCC, not API review.
Yeah, except for maybe asserts, I don't see us changing any calls to it.
Great. All right. I think we're done with this one. Back to Span. Back to offering, yes.
Okay, so our favorite topic. Can we start with bit converter for just 1 minute?
Seriously?
Yeah, I just have one question. So I was making issues last night, and for both bit converter and GUID, I had a question. So try write bytes. I'd initially assumed that we didn't have to tell the caller how many bytes were being written because, well, if they're writing a long, it's 8, and if they're writing a float, it's 4 and whatnot. But do we think we need an out parameter that says how many bytes were written? Same question would go for GUID.
Isn't it still as simple as doing a size of those types to get that information?
Yeah, like especially because these are all fixed size, and so if we do precondition checks, we'll either have written the size that they should know or nothing. So I don't think we need the out.
Okay.
So how big is bool? It's 1 byte.
I think whatever size the bool is.
Exactly, but what size is it?
Size of bool.
Yeah. Type size
You can write size of bool and code. We'll give you an answer.
Is that actually the right answer though?
It is the right answer.
Because I had a discussion at some point, like size of structs, for example, do not actually match how big they are, because one of them is the interrupt size, the other one is the actual size, how we lay it out, and they may not all agree.
Correct. A class with auto layout gets weird on site, which is why size of requires unsafe on anything other than the super primitive types.
Yeah, bool is not blittable, no matter what you do.
Okay, so that was my initial thought as well, which is why I didn't include out here. So people can just do size of. What about for GUID? If we want to, I mean, size of GUID does produce the correct answer.
Does it? You have to use Marshall.
But you need to use unsafe code to call size of on a GUID.
Or Marshall.size of.
Or Marshall. I haven't verified that that was the right thing. 1 sec. Size of GUID.
Good.
Yeah, it does.
What does size of bool give you, though?
1.
Interesting.
Yeah, that makes sense, though.
Oh, sorry, wait. You said size of. Did you mean Marshall.sizeof? Because Marshall.sizeof bool gives you 4.
That's what I thought.
But size of bool gives you 1.
What's the purpose of size of bool if it doesn't match the native size?
Size of bool with how big it is in .NET. Marshall.size of bool with how big it will be.
But why would I ever want to know that if I'm not just like blicking stuff into space?
For try write bytes.
What is the behavior there? Does try write bytes write?
It writes a 1 or a 0.
Huh?
It writes 1 or 0 as a byte.
If we document that, that's fine.
I believe it's already documented for pit converter.
Okay. Just we do weird things with.
I guess, technically speaking, having them doesn't hurt because you can now do the out underscore thing. So, just a question of if we care about the extra assignment opcode.
I'd say no. I just want this one case just needs documented.
Fair enough.
Okay, and same for GUID?
GUID is always the same, yeah.
Okay.
I mean, the question is whether we want... I mean, to be fair, I think size of is annoying because you have to be unsafe, right?
Well, size of for all of these built-in types, no. You no longer have to be. But for GUID, you do have to be unsafe.
Oh, interesting. Because, oh, I see.
And there's a feature pending that's going to get rid of that. The blittable structs. So you can attribute where structs to. We would do that for GUID and all the rest that would allow C# to, because it really isn't an unsafe operation for GUID. We just make you do it.
So maybe for now, say no, we'll leave it off and we reevaluate in the future.
Yeah, if we need it later, we can add it.
Yeah.
All right. That was my bit converter question. Moving on.
Did you see that I added some more notes to the thing yesterday? I merged them from last time, and there was one thing that we added last time, which was endianness.
Oh, right.
Did we want to tackle that?
Was that? But that was sort of a. I thought we had decided that was sort of a largely separate issue. Like we could add endianness overloads today as well. We just haven't, and if we wanted to do it, it would just be overloads of these methods.
Right. I mean, like the only notes that I have is we should take endianness into account and provide overloads that allows consumers to specify the endianness they want. And that's the only thing we left with that. I mean, like, yeah, I agree with you that this is a separate issue.
Yeah.
I mean, I'm fine with that.
We should probably write down that issue so that we actually, at some point, we're to come back and talk about it. But I don't think that we would want to address it as part of this change.
Yeah.
Because then we'll just argue about what the Indian instruction.
Yeah.
You know.
Right.
All right. So I think we left off in the stream section.
Yeah. Let's have my mouse. I can scroll again. So this was the last time we tackled, and then text reader, text writer.
So this is very similar in nature to stream. Synchronous methods taking span, asynchronous ones taking buffer. Basically, the core virtual methods that we have on text reader and text writer today that worked with char arrays, I've added them with spans and buffers.
We worked out what our deferral pattern is going to be.
Yeah, so I think the only thing that makes sense, like in the stream case, is So there are two deferral issues. One is what do we defer to, and the other is when can we do more optimal things in derived implementations. So for the deferral thing, basically there's a corresponding method for all of these, and I think we just delegate to that one. So read span, read span char span delegates to read char array, whatever it's called. I think that's pretty straightforward. The other issue is the one we had an email thread on, where we want to then override these methods, like on stream. MemoryStream would override the new read async, write async methods. The trouble is, it wants to do the more efficient thing, but that more efficient thing involves not calling the corresponding method. But what if someone derived from MemoryStream and overrode those other methods? They would still presumably expect their overwritten method to be called. And so our overrides on our streams are going to have to do some sort of, currently the best thing we can do really is just a type check. Are we a concrete memory stream? If yes, do the more efficient thing. If no, call to the base, which will end up doing the delegation. And what I don't have in this issue, but which we should talk about we should talk about now, it's probably a good time as any, is if we want to, we could then expose out from our concrete streams that are not sealed a protected version of the more efficient implementation, which the public method would just call, and derived types could call if they wanted to as well. So MemoryStream's efficient implementation just copies between two in-memory buffers, basically. So we would have a protected method that just copied between the buffers. We would have the public method that called the protected method, but only if it was a concrete memory stream. If not, it would call to the base. And then a derived type, if it was overriding the method entirely, it wouldn't have to do anything. If it wasn't, it could choose to override it and call the base protected method.
And presumably we'd have to do the same thing in stream reader and string reader and all our other non-sealed.
Exactly. Yeah, unfortunately, we have a bunch of these unsealed. Well, fortunately or unfortunately, depending on how you look at it, we have a bunch of these unsealed types.
Yeah. So I guess I'm wondering if in something like text reader, if we could do, so find the place that we can make the best, shared implementation, and then like in the constructor of that type, set a protected or set a private Boolean based off of doing the type check, so we only do it at construction time and not, every call into read.
I mean, it's an implementation detail. We can do that. I don't know that it's actually going to make a difference, but we could check. I have not compared the perf of the JIT optimizes get type equals type of blah, and I haven't compared the perf of that versus the extra space to store a bool, which may or may not increase the size of the type, and the field read.
Yeah, I guess I just don't know if we want to make it be, am I this type, or if it's going to become a list of types, or if it's going to become if I'm defined in any BCL assembly, or...
I think the check, as I've thought of it, is going to be, if I'm in type foo, if get type equals type of foo, then X, else the Y.
Fair enough.
But it's possible we could do perf testing and find that it's better to do that check in the constructor and cache it, in which case we can totally do that. It's hidden from the API surface area.
Yeah, I'm just wondering if there are places that we have like a middle class, which is where the right place to, like, that we have like 8 different derived types, and we're like, well, we want them all to use the good thing now.
Yeah, it's pretty rare actually that we have an intermediate type, at least in streams. There's like 1 or 2 cases I can think of. I think like SSL stream derives from. No, but even then, it's pretty rare. I think it's the only one I saw was isolated file stream deriving from file stream, maybe. But I think we should just deal with it on a case-by-case basis.
All right. Do we want to introduce an interface kind of query for this these optimizations? What are the akin to has buffer? But
can you elaborate? I'm not sure what that would look like.
Well, you're basically going to be doing type check for specific streams like MemoryStream, but it seems like you don't necessarily need to do that if you just meet it.
Well, no, the issue is in the type itself, you need to check whether you are that type.
Yeah, like if we slap I support span on MemoryStream, a derived MemoryStream says I support span, but they didn't really.
I was thinking about it being that instance of that type. I was thinking of wrapping.
Yeah. So, Steve, I know that you've over the years found lots of streams that didn't do task-based async, right, etc. Are we going to have a confidence that we'll have a good way of finding what all the places we need to spanify are, or is that going to be another bug tail?
Well, I think the base implementations will just work. It'll be a question of, are they as efficient as they could be? The base implementations will either, like for the buffer taking ones, like if the buffer wraps an array, they will just be functionally and almost performance-wise equivalent to the array ones we already have. And otherwise, there'll be the extra cost of array pool interaction. I think the tail will be streams where there is something more efficient that can be done, and having to go and do the overrides on all of them. So I don't think we're going to find much of a functional bug tail, but there could be a perf bug tail. There's something like 10 or 12 streams in corefx and core CLR where it's going to be important that we go and override these for performance reasons.
Fair enough. Yeah, perf tail is more what I was worried about.
Yeah. It's not going to be nearly as bad as some of the blocking, deadlocking issues we saw, but those were mainly due to the issue where we had completely removed the intermediate begin-end methods in some profiles, and because of that, we introduced a whole host of potential problems if you ran on a platform that actually had them. But yeah, we are going to have, I expect there will be a tail of stream implementations where, oh, right, we have to go implement these there as well. So I will proactively open issues for all the ones that I can find in Core CLR and corefx, but we'll probably need to track down and help others in their own repos, do the more efficient thing. The interesting part will be when people start consuming these, if someone's using a newer .NET Core that has these methods, and so they're consuming them, and someone else has targeted net standard and thus hasn't overridden these, you're going to get the base implementation, which will at best be as efficient as the current stuff, but may actually add a little bit of overhead.
So we're looking at the text reader and writer, but we're talking about the streams.
It's the same. It was just the delegation thing. It's the same issue in both cases.
What the reader writers are, you're going to be wrapping streams, which is why I was thinking about the marker interfaces in my head. But you're basically going to take in a stream and you're going to do potential different calls based on the stream and type itself.
Potentially, although my assumption, and maybe incorrectly, my assumption is that if you're given a span or you're given a buffer, you're going to call the corresponding
load on the stream.
One on the stream. Although we'd have to look at the implementation. It probably depends. I mean, we may not even change the implementation, or rather, we may change the implementation. Like, I think if I remember correctly, Stream Reader has one method that it always goes through to read to fill its buffer from the underlying stream, to fill its array. And so no matter which of these entry points we're using, you're basically going to end up there. We will probably actually go and change that one to always use the new span and buffer based APIs, because in the 99% case, they will be more efficient. But so yeah, I don't think it's going to matter. Yeah, I don't know. Maybe if we had such a marker interface, it would switch. It would say if it implements those, great, use them. Otherwise, don't. But that probably leads to its own complexities.
Yeah, that reminds me of when our two screens.
Yeah, I know. One other question that popped in my head, maybe we talked about it and I missed it, but Why is the read returning value task and the write returning task?
So task, you can always, there is only one possible completed task. It is task. There are an infinite number of possible, well, not infinite, there are 4 billion possible int return values. So there is a single cached task, task.completed task, which you can always return, but there is, we can't cache 4 billion task of ints. So we return value tasks, so you don't have to allocate to return the value.
But you're assuming that everything's going to return task.completed on these things. Obviously, it's not going to be that way.
Well, but
if it's async, then value task wraps the task.
Yeah. I mean, the general assumption is when you do read async on a buffer, that the underlying buffer is bigger than what you pass in. So the idea is that in the majority of cases, you can just return the completed task. And then every once in a while, you actually have to do an async operation. So like amortized wise, you allocate that.
But why is writing different?
Yeah, because writing, as Stephen said, you can cache the tasks. In that case, you don't have to differentiate.
If you're assuming everything's going to be, most of the majority of things are going to be completed.
Right.
If no, we're not. So if things complete asynchronously, there's nothing to cache anyway. A task is going to be allocated whether it was returning task or returning value task.
Okay. Do we have any guidelines around when to use value task versus task now in our API designs?
I believe we do.
We have shared guidance in various forms on various posts and whatnot. I don't know if we actually have any in the docs. We should. My guidance has basically been, if your API is always going to return asynchronously, just use the task. If your API is going to return a fixed number of possible values, like if it's either non-generic or it returns a bool or something other with a fixed number of possible results, then return task a bool, etc. If there's a high likelihood that it's going to return synchronously and it's impossible to cache all possible results, then use value task. The problem is value task isn't always a win. Like it's bigger than a task, for example, because it contains a reference to a task n to the t. And so, for example, if you await a value task returning function, your state machine will have an extra field in it, more than what it would have had in the task. And every call to access this goes through an extra branch, and et cetera, et cetera. So there is a small amount of overhead associated with something being a value task. So it has a lot of upside if you expect things to return synchronously. But if you don't, or if it's pure overhead, it's not worth paying the extra cost for.
I just find it's going to be quite difficult for our customers to figure out when to use one or the other. But
these are the docs.
Might just be me also not getting fully ramped into it yet.
So the docs for major tasks in the remarks section go into the trade-off decision and provide guidances and look at perf.
Did we pull these out of the XML comments? Because I
believe we did.
Oh, cool, excellent.
Probably need some cleanup. Like there's some markup here that's fucked up, but hey.
Cool. All right.
So we have something there. Right, sweet.
I don't really like the symmetry is not there, but I guess I can understand the reason. That's why.
Yeah, that's generally sad.
I mean, we've gone. I've been asked this a bunch in the past. Like, why not have a non-generic value task? We could add one. It would add 0 value other than naming symmetry.
Yeah. And these are two different types, so the symmetry is not as isolated. But when you look at stream, it's more like, oh yeah, you have read and write, returning different tasks. But.
Yeah, I get it. I don't have a good answer.
There's not one necessarily. I mean,
get a time machine, fix it in V1.
That's a great answer.
See, I'm always open for it.
Although I've seen those movies, what ends up happening is you end up going a little bit into the future, and then you fall asleep, and then you end up like 4,000 years in the future, and it never works out.
And then the Morlocks eat you.
Exactly.
And then suddenly Biff Tannen rules the world because you slept too long.
Did we make a call about interface IHAS buffer?
Sorry?
Briefly, did we review the IHAS buffer part?
we did last time.
We talked about it briefly when the
So we talked about
that.
that it's something we should be looking
Time machine and
We haven't really. Yeah, so what we had last time is the set of public types. These could be internal. So this was the buffer stream versus read-only buffer
Yeah,
stream.
we talked about those.
Instead of public types, this could be internal, and we can have a factory method that returns you a stream. We'll probably require the IHAS buffer pattern to make sure it's able to tell us explicit types. And I think that just requires a complete proposal, I think.
So you want to tie it together with that? Or because I thought we also said it might actually have benefits for existing streams like MemoryStream and others.
Does it though?
I think it potentially might. So there are some places where code will check whether it can get the array from a memory stream, for example, and if it can't, like it'll type check, is this a memory stream? If it's a memory stream, can I get its array? If it can, then I can do various things based on that. And so having the interface, if we implemented it on MemoryStream, on it, MemoryStream, buffer, unmanaged MemoryStream, and I guess read-only buffer stream, we could potentially expand some of those optimizations to be broader.
So I have a more general question now. Should we start filing individual issues for those things so we don't lose track of them? Because I think having this I
agree. I think this is probably
I think we should. I wanted this one issue as a way to kind of go through everything together, but I've already started opening separate issues. If you scroll up, you'll see places where I said separate it out as XYZ, issue. And my goal would be that once we're done with this review, we can close this issue and just have the individual issues that people can tackle individually. So I will make sure that everything has individual issues, and then we can close this.
Okay. So can you repeat which streams you think? This is basically, so buffer stream, read-only buffer stream.
You're asking about the IHAS buffer?
Yeah, that would, and then there was.
Off the top of my head, I think it would be MemoryStream, unmanaged MemoryStream, and then the new, whatever we call them, buffer stream and read-only buffer stream, or maybe they're just internal types and it implements it on the internal types. There may be some other streams as well. I mean, it's possible. You could even imagine. You could imagine implementing it on wrapper streams as well, and it would just, check whether the stream that it was wrapping implemented the interface, and then if it did, delegate to it. If it didn't, return false.
The problem with that's exactly why I was skeptical of the value of this thing, is because as soon as you have delegation, the interface check alone doesn't actually help you, right? Because you have to statically decide whether you dynamically wrap one that does, and then you would always have to implement the interface. The interface itself would have to have a query method, at which point you might as well just add it to the base.
Well, that's true. I mean, we could just add it to stream. It's already a try method, so it can already fail. Even on something like MemoryStream, it can fail, because when you construct a MemoryStream, you can say, I don't want my buffer exposed, and then try GetBuffer will fail, or try getArray, whatever it's called.
Yeah. Allegedly, we could make the.
That's true. We could just make it. We could just add virtuals to the base stream.
Which I think this is my general, gut that I developed. I think as soon as you have the dynamic delegation scenarios, you're better off adding it to the abstraction itself rather than doing interfaces, because then you always end up with lying anyways.
Yeah.
What is it called? Trigate Buffer?
That was my suggested name, yeah. Because I think MemoryStreams is maybe try getArray. I don't remember. Oh, no, MemoryStreams is called try GetBuffer.
Now that we possibly have a type called buffer, that's only slightly confusing.
Yeah.
Well, yeah, that's the general problem that we have with.
Oh, it'll be even more confusing. There was some talk about renaming buffer to memory, at which point MemoryStream is a total misnomer.
Yeah, we're running out of names for buffers.
We should just call it emo.
Oh yeah, you should emo up. But only if you rename task to a tome of T. That would be also cool.
Perfect.
Then we can also have symmetry on that one. All right, so.
All right, so file. I'd initially had a larger list here, but I trimmed it back for now. Basically, all right, let's start with the write all and append all because I think those are easier.
Yeah.
You give it a path. We already have byte array versions of these, so this is just the span versions. Basically, you call it and you give it the data you want. It opens the file, it writes it out, it closes the file, and write and append versions of those. The read ones are more complicated, and I don't know what the right answer here is. So you can read, but you don't necessarily know how big your span is. So you could I have this out long to tell you how much extra space might have been needed. But I really wasn't sure what to do here.
Like, I mean, that seems like literally a super inefficient API, right? Because you keep opening and closing the file, essentially.
Exactly. And at that point, you talk, right, well, maybe we have some kind of handle that we can use. So you then have you open the handle and then you pass the open in. But at that point, you're almost to the point of having file stream. So you could potentially have like safe file handle and give safe file handle an open method, and then have these read all bytes, excuse me, methods taking a safe file handle. So maybe that's something we want to consider for the future. You potentially have a similar thing with write all, by the way, because you might, if you're getting your data in increments and spans, you may potentially similarly be writing 4K bytes, writing 4K bytes, writing 4K bytes. So we're in sort of this gray area here.
I mean, is there significant overhead to file stream that would make exposing file handle based write operations significantly better?
If you know what you're doing and you set the file stream's buffer size to 1, which basically means don't buffer, I would expect that the overhead is basically the cost of the stream itself. Any virtual calls you might be making and the actual object that you allocate in memory. So I would be surprised if it was substantial.
So,
I mean, the only thing we could consider is having this method in such a way that it matches the existing one, which means it will only ever succeed if your buffer is large enough.
Well, the read all gives you back an array. It makes it be big enough.
Right, but in this case, you would be on the hook to pre-allocate the right size, which is either you can ask for the size up front, right?
Sort of. You can ask what the size is, and then later you can read, but it's not necessarily the same file.
True. In which case, I mean, you just combine it into this one method. And
I think we blow up if that happens. So
reading this API script, I don't even know what remaining means. Is it meaning the remaining bits that need to be read from the file?
Yeah, how many bytes are left in the file that weren't read? That's what I'd intended, at least. But like I said, these all get into this complicated territory, and it could be that the value added here is so little, you may as well just do, open this file.open write, make a call on the stream, because at that point you can just call, stream.write and pass in the buffer or the span, and you close it. So maybe these helpers are no longer particularly valuable.
I mean, I can the write and append, because there's no, you didn't give me a big enough thing. Those seem easy, but again, they're also easily added later if people complain about them. But the read one definitely seems weird.
Yeah,
I agree. It seems weird to me too.
I mean, honestly, those ones, the reason why I like those is that they're effectively the printf of binary data debugging. You can just say, I have a buffer, just dump it to a file, let me just look at it in a hex view or something.
You don't have to write a using because we did it for you.
Exactly. So I think they are just convenient. I would still have those, but I mean, in a highly performant app, it's also not something you would use a lot, right? But they're just super freaking convenient when you have a span in your hand. Versus these ones are just they're like in the worst possible triangle, right? They're not efficient and they're not convenient. Yeah. So
the file.readAllBytes is, I don't know, just give me a thing that's big enough and I don't feel like pumping the string.
I would argue that AppendAllBytes is also, but like RightAltText, because you're going to wipe out the stream, like you have to be writing the full thing. So it kind of it's sort of the most efficient thing you could do. AppendAllBytes, I would worry that you're going to be using this in some sort of repeated fashion where you're going to get 10 bytes and write them out, 10 bytes and write them out, and then you're going to be repeated. It's going to have the exact same read issue. So maybe we just say we'll add the write ones and not the append and not the read.
I think I'm fine with that. That seems to be a good place to start.
Yeah, it's good with me.
And let people come back with scenarios that we might be missing.
Wouldn't we also want to write all chars for SpanOfChar?
Do we have write all characters with character array?
Not character array, but we have write all text from a string. So.
Oh, that's true.
We'd have to route that through encoding.
Not if it's a char, right?
Yeah. Can't write chars to a file or to disk. Write bytes to disk. Then we have to pick an encoding for you.
Well, I argue it's the same as RightAltText.
Yeah, whatever RightAltText does, but
those ones I would say that I don't think they will be commonly called. I mean, honestly, I'm fine with just having the separate one because it is something you can imagine in real world, and as I said, to me, it's the printf of binary data. And I was like, well,
yeah.
I mean, the only thing why maybe append all bytes is useful is essentially if you have a loop and you want to printf the whole thing that you looped over, append all bytes can be very convenient. I mean, it's not efficient, but at least when you run your program, you don't have to like do crazy gymnastics in the code to get it to the point to dump the whole thing, right?
Yeah, but at that point, like, all it takes is one extra line at the beginning of the file and two braces to say open the file for writing, and then you just call stream dot.
And if you want a OneShot, you can make a static class that holds a static file stream.
Yeah, most of these are supposed to be OneShot APIs on the file.
Yeah, I mean, as I said, like, I'm fine with just keeping that for now and see where it leads us.
I missed it. Where did we land on Wes's suggestion of RightAltText and RightAltText async?
Yeah, to me, those are kind of odd because, as Jeremy said, you kind of have to pick an encoding, but you also have to.
It's so different than you just basically creating a string with the read-only char. Though.
It is, but like, is it a common scenario? I don't know.
The RightAltText also has overloaded text and encoding. But I don't know.
I mean, to be honest, like, I haven't really
spent chars yet. I'm not sure yet.
Yeah, that's exactly the thing. Is like, I'm not convinced that SpanOfChar will be as common as stream will be. Maybe I'm wrong, but I don't see that yet.
Well, but I mean, read-only SpanOfChar is string. We can add the string overload too, but
yeah. Just a question. Maybe. I think it's fine to leave it out for now. We can add it if it felt like it's necessary and useful.
Yeah, I mean, like, because really what we'd want to do is, so if somebody has a string, they can still call RightAltText, and then we would just want to have changed the plumbing of that to use a non-allocating thing if that's our goal. So the question would be, when would somebody have a read-only span of char? I guess if they substringed. Sorry, if they sliced string?
Yeah.
So non-allocated substring is the scenario. Feels marginal but not difficult. So maybe it's worth doing.
This is something where I think we can be somewhat more reactive.
Yeah. This entire API, a file in general.
I mean,
It's a convenience method. It's not about performance.
I mean, what Stephen just said, like, is somewhat convincing me. Is like, even WriteAltBytes, you could argue like you really need it.
That's right.
So I mean, I given that you already deleted the remaining ones, maybe we should just start with a file that doesn't have any overloads and until proven otherwise.
I think that's also a reasonable starting place.
Because at least it's somewhat consistent, right? Otherwise, it's a bit weird to have only a chunk of it.
All right, let's do that. We'll just scrap this whole thing, this whole section, and we'll revisit it as we find real need for it.
I agree.
All right, Stream Builder. That one seems more like a no-brainer to me.
Shouldn't there also be a format overload, or is that the append?
There is a form like where you basically pass it the string format and the arguments.
Yeah.
That point efficiency is already out the window, I guess.
No, but I think that's one of the biggest APIs we need to help improve and plumb through Span.
In Midori,
So wait,
I wrote a non-allocating or a minimally allocating string.format.
How minimal was minimal?
The only time that it had to do complicated allocations is if you did the like open curly 0 colon and then wrote a custom format, because then in order to call legacy APIs, I had to call it, take that as a substring and pass it to somebody else.
Right.
That was the only time it allocated, other than the fact that you asked it to copy memory around.
so I don't have a great sense. Like, so unless we added some sort of specific overloads for it, I don't know how we would. You wouldn't use this read-only span of char as the arguments that were like inserted into the format string. And at least in my experience, most times the format string isn't dynamically generated. It's some fixed bit of text with the holes to be filled in, which wouldn't be a read-only span of char either. So where would a span fit into a format?
I mean, I think maybe it's not even a public API, but it would be internally. I feel like we need to get a sort of a good code path through the append logic and string builder, such that we can use spans as the buffers that we're writing to as we're building these things up, so we don't have to allocate. If we can eliminate a lot of allocations.
Oh, we should be, obviously internally we should do whatever we can to fix implementation details, but I'm wondering, like, what is the API signature with format that would involve span?
Like, if we don't already have a plan of having read-only span of char format or console.out the same as string, we probably want to make it do so that we don't have allocation just to print a substring.
That's interesting. You're saying a string.format, a string.try format that takes all the arguments that string.format does, but a span as well.
Yeah, well, like if I pass
format into a span rather than formatting into a string.
Well, that's one thing, but I'm saying actually passing a span or buffer or whatever as, because if span can't be boxed, then that would be weird. But having it as an argument, so that if I have a string and I want to, instead of substring it, which is allocating, slice it to get non-allocating, and then say, go write that to the console.
Right. Well, that's where I don't know how we do that with a format, unless you like. So if the format string is, foo, open brace 0, close brace, bar, open brace 1, close brace, and I want to use span as the first argument or the second argument to be filled in, we would have to have overloads for every possible position span could be in for all possible arguments to be filled in the format string.
So span can't box?
It can't be boxed to the object, and it can't be generic type parameter.
That's really convenient.
At the high level, I'm thinking the static API on string, the string.format API. If we pass in a span, you basically do all the formatting into that buffer. Well, behind the scenes, string format plus string builder, which would need to be passed through or use that buffer as well. So I don't know what APIs we need to make that all.
Yeah, like, can we get a read-only buffer of string via any sort of slicing method?
A read-only buffer of char, you mean?
Yeah.
No.
Because like people love substring, and people love stringed up format, and right now we're saying that those two things don't play well together with spans, or with lower allocation.
Yeah. So you're saying.
I think that we need.
You're saying get a read-only buffer from string. I don't believe we have any way to do that, and then also have string builder.format methods that take 1, 2, 3, 4, 5, 6, whatever generic type arguments, such that you could pass a read-only buffer as one of those without boxing it.
I don't care if it gets boxed or not. I just care that if it gets dropped in position 3, that we write the characters down instead of like an object hash code.
I make a proposal. To me, it sounds like string formatting and span is a larger topic in and of itself.
Yeah.
Maybe we should just spend another meeting just talking about that.
Yeah, I mean, most of at the end of the day, string builder is going. Hopefully, it'll end up using. Like today, it's really inefficient. You call string builder.append or string builder.whatever and int32. It first calls toString on the int32, and then it writes that string to its underlining thing. Like we should just fix that, and we can fix that easily once we have methods like int32.tryFormat with a span. Like it'll be trivial. The whole format string thing. I agree. You know, if we had a string format that instead of generating a string wrote to a span of char, like that seems pretty nice. But maybe I agree. Maybe we should separate out that higher level format strings thing into a separate issue, and someone tackles that directly and make sure end to end it looks nice.
The last question for String Builder for me is: should we also have a constructor that takes a buffer that basically can be used as the underlying structure for the memory from String Builder? I don't know how much that would gut the String Builder implementation, but
so right now, String Builder is a linked list of string builders.
Yep.
And I don't remember. I think it stores its data under the covers in each of those segments as a char array, if I'm remembering correctly.
Yes.
Yeah. So you're saying basically instead of storing it as a char array, store it as a buffer of char.
Yeah, try to reuse the buffer. No. I don't know if it actually helps that much either, but I'm just thinking.
If it didn't hurt existing perf on String Builder to do that, seems perfectly reasonable. I mean, MemoryStream allows you to either dynamically generate the memory it uses, or you can pass it in. Seems reasonable for String Builder to do the same thing.
You'd have to deal with not chunking.
Yeah, you basically have a flag about whether you were allowed to expand the String Builder or not.
Right.
Yeah. But if it just replaced char array with buffer, do we gain anything?
Just replacing char array with buffer, no. But if you were then able to pass in either, I mean, you could do the same thing today. You could give the String Builder the underlying char array you wanted to do. We just don't have that constructor.
Right.
And
there's a lot of rechunking that goes on in String Builder too. So there's a new char array shows up quite a lot in the code.
Yeah, I think it's an interesting idea that should be left as an orthogonal unrelated issue to be addressed separately.
Fair enough.
But it would potentially alleviate the need for something like String Builder cache, because well, maybe not. You still need to allocate the String Builder. Yeah, I don't know.
All right.
All right, so encoding. The encoding class already has a bazillion methods on it. but that work in terms of char stars and char arrays. But there's a small hand if you just add a few that work with span. You could basically use encoding without having to worry about allocating arrays and the like. You guys still there?
Yeah.
Okay, cool.
Thinking.
I'm just bringing up the other encoding APIs too. Just look there.
To me, that seems generally fairly straightforward. What's the preamble thing?
So that was one that Justin Van Patten and Jan had both talked about adding. Today, there's a get preamble method that returns a byte array containing the preamble for the encoding, like the BOM. And if we did it as a property that just returned a read-only span, we could simply have an encoding cache an array of its preamble, and then always just return a read-only span around that same array, which alleviates the need to allocate. Because today it can't do that in case someone changes the returned array.
Yeah. I mean, we'd be vulnerable to jerks. But
yes.
I think that we've decided in general we don't care about jerks.
Right. You can call the dangerous get pinnable reference or whatever it is, and then change the data.
Yeah. I mean, there's generally true form with anything you return. I mean,
yeah.
You're really into unsafe. You can always do crazy stuff.
I mean, I'm just pointing it out and making sure that we're still okay with. We don't care if you.
It's a good point. I raised a similar issue, and I think Jan's point was valid. It's called dangerous now that we're in a world where CAS is basically deprecated, and you're single. You're in a world where you own your destiny for your whole process. Like, you can do whatever you want, and if you mess with it, well, that's your problem.
I believe we've said that if you host stupid code, that was your fault.
Yeah.
So somebody writes a jerk library, you import the library, and they make all of your UTF-8 or UTF-8 strings have an invalid preamble. Well, I guess they can't because UTF-8 has no preamble. But UTF-16, write the wrong bomb.
I'd argue this is even consistent with a world of CAS, right? I mean, like, we had private reflection, and we just disabled that, disallowed it in CAS, right? In the same way, once you call those APIs, you could disallow them in CAS as well. I mean, it's just about speed bumps, right?
Right. No, so I'm pretty sure that we have decided that we don't care about unsafe or dangerous, and that if you do something to screw up your own process, that's bad.
Yep.
But if you can do something to screw up someone's remote process, then that's a security bug. And this wouldn't be one of those.
I mean, do we still, for our general question of to try methods, do we have a common rule that's going to be returned here for the error case? Is it going to still be like your output buffer is not big enough?
Well, so these cases actually have existing methods. So like encoding dot. Wait, let me bring it up. Try.
Can you try get?
Where is it? Get. Actually, they're not called try. So wait, did I call them try in the issue? Maybe I did.
Yeah.
Maybe we shouldn't. Like, there's already an encoding.getBytes method that takes a char star and a char count and a byte star and a byte count and returns an int. So maybe we shouldn't even call these try. We should just emulate the existing methods.
Well, the one that takes a char star doesn't. I guess it takes the byte count. I was gonna say it doesn't really have a bound, so it just sort of like destroys memory.
Right. It has both a char count on the input and a byte count on the output.
It looks like it's still, they're both inputs. I don't see an outparam.
Well, it returns how many bytes were written, but byte count is the bounding on the array.
Yeah, the thing that Christoph had pushed back on a little here was it doesn't return how many chars were consumed, which this version, I believe, does. Yeah. So if you wanted to, like, you know, you're reading along, you run out of destination space, so now you want to like pick up where you left off. The current methods don't tell you how to do that because they don't tell you where you left off in your chars or your input bytes. So these methods that I added do.
And so the idea is that if you didn't consume them all, you would slice the current chars you have, span you have, and then call it again.
Exactly.
So isn't that something we decided we want to like have uniformity and always return the transform encoding, the transform status?
If it has obvious illegal data.
No, even for cases where you don't have illegal data, that's what they do in corefx lab, right? They just have a uniformity in the, you indicate the error condition to the caller. Did you run out of source stuff? Did you run out of target stuff, right? These are there's two cases you can have. Actually verify that as I'm saying that.
Source stuff you wouldn't worry about. If you run out of sourcing, that's exactly what you want. You wouldn't be able to write them all to your destination.
Yeah.
Well, I guess the concern is if you run out of source in the middle of a transfer, like if you only have half of your UTF-16 character available.
Or the opening of a surrogate pair.
Yes,
yeah.
That's invalidated, but yeah, right.
Well, it's not invalid data. Like invalid data would be the data you've provided to me, like it will never be transformable into the output. Whereas this is, you need to give me a little bit more before I can continue.
Like that stream, well, it gave you all the bytes it had at the time.
Can recover.
Back up one. So it looks like the get bytes that takes pointers, at least for some of the encoding types, that results in an exception if it didn't have enough space. So if we didn't make this try get bytes, then we would have to inherit the same, do I just stop or do I be exceptional? Right. So probably just moving to a try pattern or moving to the transform status is just cleaner.
Yeah.
Honestly, like I think that, to me, considering the complexity of calling APIs, having uniformity in the appearance, I think is very important. So I'd rather move to, like, if either we do bools across the board or we do transformation status across the board. I think one of the two, like, it's either one of them, right? And considering that the bool doesn't work in all cases, it's probably going to be the enum.
Wait, so you mean you want to go back for all the places where we've talked about adding bool try thus far? You want to change those to returning an enum?
That would be my standard position, because I think it's easier, right? Because then you can say, yep, in this case, illegal data can never occur, but destination too small needs more source data, or done can always occur.
So bitconverter.try_WriteBytes returns a transformation status?
Yeah, I'm not sure they do try. I think what they do in the corefx lab, they just call it encode or transform or something to that extent. So I think we have to keep, I don't know whether we just go with get at that point. It may be weird.
For these encoding ones, I think we should just give it a try and make it be symmetric with the existing APIs on encoding.
So we just go with get bytes and then return transformation status?
No, I haven't returned an int for the number of bit bytes written, which is what all the other get bytes do.
Well, yeah, the problem is that good enough?
I think it is. We still have the op parameter for the consume chars or consume bytes.
What? Yeah.
So you think that somebody would return this, derive the success status by chars consumed being equal to chars.length?
I mean, the general pattern that they have at corefx lab is, right, they have source, they have destination, they have consumed, they have written as out, and return transformation status. That's what they have across the board. And I think that's actually quite nice.
We do need to take into consideration the existing APIs on code.
No, I don't believe so, because if you change your code from byte arrays to spans, it's not a drop-in replacement. You have to rewrite the entire, like the way you call the APIs will be different. And so I think if you always move into the same pattern, it's much easier as if you move to pattern A in class A into pattern B in class C. And then
we have the pointer versions already there. Now, I'm not even talking about the array versions.
No, I know, but the pointer version is also done with the semantics you want.
Right.
Yeah, so you have to do something else anyway. Like, I mean, currently you basically have to catch an exception when you're too small. You should recover from that. So the whole point is, like, whatever code you have currently, like, you have to change the way you set it
There
up.
won't be any exceptions. Only exceptions should be argument exceptions, which is exactly.
Well, that's what Jeremy just said. He just said, like, when
There's a property on encoder which is throw on overflow, which throws if it hits a point where there's not enough space in the destination. I don't know who said
all the get bytes. I'm looking at here. Check the bounds before you start writing.
the ones that
They're raised and then they go.
the get bytes that takes a char star and a byte star.
Yeah. Where's the overflow exception?
All right, so get bytes calls get bytes. Then I followed byte count to line. I guess I'm in ASCII encoding right now. Line 630, throw bytes overflow. Because if it does,
We would ignore that global property on encoding for these APIs then.
yes, it sometimes throws. There's a conditional throw that I don't understand. I just found it while looking to see what our current behavior was.
Even in that case, if there's an argument exception. Generally, input.
Well, there's input issues like you gave me null, and then there's data issues like FFFF is not a legal start value.
Even when we start doing this, there's a bunch of other exceptions that look like it can come out too. When you start factoring in encoding fallbacks and other things.
Of their invalid data, or
Well, the fallbacks, essentially we call back into a delegate and they can do whatever the heck they want.
Yeah, it's the general problem with, like, adding these two existing types. I mean, I think our principle has been that we generally want to keep the semantics of the existing type, meaning the kind of issues that we are throwing for, not throwing for, should be about the same. I think, though, like, if we really want to deal with spans, we kind of have to make a decision what's more important for us. I think, generally speaking, when you move to spans, I believe we should make sure that when we call these methods, we generally don't throw for size issues. I think size issues should be just communicated through the pattern. Because otherwise you have a really hard time using span-based overloads, you know, across the BCL, because in some cases it throws, in other cases it doesn't. I think that's where having a bit more, I think, symmetry with the usage,
I'm not entirely sure we can be successful in that.
Because you don't think you can plug it through in all cases? Or?
Yeah, like a lot of, I mean, I'm looking at some of the custom encoders that we have. We basically have to go rewrite all these custom encoders in order to flow them properly if you want this thing to run.
if they have
We all implemented the same.
if they have a fallback, or sorry, if they take a delegate, we can't pass the span to the delegate. So either these would need to take a buffer, or we'll need to do complicated.
Fallbacks can change the size of the outputs and inputs. I'm sorry, not the inputs, but the outputs. based on
Yeah, I mean,
widening.
what you just said. I think is a slightly orthogonal angle, which is like can we do spans in principle, right? Period. And then I think yours is more like for the error conditions that we have. I mean, the one thing you could do, you could just catch the exception and return the appropriate error code, right? It may still be better than propagating.
At that point, I'm not sure it's better or not.
But you know what I mean? Like I think otherwise it will be this weird dance where you kind of have to read the docs now across the board every single time you call the span-based API.
Or what you kind of use the same pattern that already exists in those APIs, and people are kind of used to it.
So the other option is we come up with a word that is synonymous with try but isn't try.
Yeah, so before we go there, like I think the issue of what you just suggested, I think it generally doesn't hold, because the problem is that the existing APIs largely produce arrays, versus the
not the pointer ones.
Well, the pointer ones are slightly different.
This is why I'm thinking these are pretty much exactly like the pointer ones, except they're the safe pointers.
The encoding ones, the way that the encoding classes work is when you call the safe API that returns an array, it calls get count, passes the data, it figures out how big the thing is going to be, and then it calls go. And then internally, they're like, well, it's stupid, we do all the work twice, so they just hope that they have a big enough buffer and then call go.
So let's separate these two issues. Like what you just said, I think I buy. Like if we have a pointer-based overload already, we should probably match that, considering that it's basically just safe pointers, if you will.
Right.
And then the other cases where we have methods that produced an array, we now move to span. Like my point there is that I don't think we can have the same semantics logically, because you have to call this thing potentially in a loop, right? And so I think in that case, the question is, what should you do? Yeah, it's going to be messy either way.
Yeah, like I'm looking at the base implementation of loop, and it's using the incoming buffer that was allocated for the byte start.
Because
okay, let's ignore like for a second like the buffer thing. The signature issue. What Jeremy just brought up is that can we do span-based overloads on encoding in principle, right? Because if we have to call delegates, then how will we do that?
We're going to have to plummet through those delegates too, if we really want to push it through the system.
which means it'll have to be converted to a buffer and then copied and whatnot. Or we also add a new delegate.
Also, sorry, the fallbacks aren't actual delegates; they're abstractions, so we can potentially add APIs to them.
Okay. Because it's the delegate type binding.
What does the fallback look like today, actually?
But
There's a base class called coding fallback, I believe.
so my comment about the word try is with try we're clearly going with the whatever we call it, the try parse pattern, which is common errors return false. And if we picked some other word, so we were introducing a new pattern, then we could still stick with, in places we would throw an exception right now, we throw an exception on invalid data, and then we only return false for a length problem, and then this would be the new, like, maybe consume GetBytes, or I don't know. I'm not a thesaurus.
Yeah, I think at some point, I think Christoph or me have to write up a few conditions that we need to handle. I think if you literally just write something and you pass in a value that is not coming from a buffer, I think try write is a very sane pattern. The other thing is if you read, then try also seems to be a sensible pattern, because you really only want to fill a buffer, and then the only error condition you can have is that the buffer is too small, right? So if the only condition you have is buffer too small, either on the destination side or on the source side, because you only have one buffer, I think try is probably not a bad pattern. As soon as you do transformation, meaning you read from one buffer, you write to another buffer, and you do processing in between, you multiply your error codes, right? And that's where I think the transform pattern is more sensible, because you no longer have a single error case.
The encoding fallbacks actually look like they're going character by character.
So they're passing literally the character to the other side?
Yeah, you're basically getting next character. There's basically a encoding fallback buffer that they call, and then you can you basically pass in an unknown character, and then you get a set of characters potentially back.
So how would they handle a surrogate?
That's exactly how they handle a circuit. You get an unknown character, and you potentially get one or more known characters back out every turn, kind of thing. Use it, and they actually have for surrogate, they basically have an overload on the fallback that takes the high and the low.
Oh, is this in the bytes to chars problem, or the chars to bytes?
I think this is probably going to end up being used in both to some degree. Depends on, there's a decoder and an encoder. So.
Oh, I guess so. The existing encoder, like, it seems like they only ever pass you a char. There's no buffers everywhere. It's like, even though it's a type called encoder fallback buffer, it really is an abstraction that you override the fallback, and then you handle basically individual chars.
Right.
So that doesn't seem bad.
So not dealing with the
besides
buffer
the
directly,
would suck,
but there's a lot of potential error conditions that can come out of it.
That's right. So I think that seems fine. So then for this case, so we have two options. Now we can either match the existing pointer-based ones, which doesn't seem to be a bad principle, or we could match the general transform pattern. Either one, I think, would be...
Personally, I think we should match the existing pointer-based one, given that we're not going to really be able to fully wrap and handle all the error cases anyways, to make it match the other pattern. We can make it match the pointer-based one with still the addition of returning the outs of the charge consumed. That's still an addition we can have.
So what would the signature be then to match the pointer one? So we would basically call this guy GetBytes. We would return an int. We would accept what source would be read-only span char. Destination would be SpanOfBytes. They would have out int chars consumed and out int bytes written.
Which is going to be redundant with return value.
That's right. So we would not have that. Yeah. All right.
If only I could see the API typing.
Yeah, I can throw it on the screen.
So.
Yeah. Actually, close this one on the left.
Yeah, I think that's looking like the way I was envisioning.
And in this case, you would throw if you didn't have enough destination space, or you would just return how many you wrote?
We would do whatever GetBytes does.
Which is return how many you wrote.
Okay.
Which is sometimes they throw, or there's a throw in there somewhere. I don't know how you hit it.
So you can determine. So it would still throw for invalid input, like bad encoding, right? And it would return, if you didn't have enough source characters, you could determine that by checking whether chars consumed equals source.length. And if you didn't have enough destination space, you could determine that by checking whether well, basically the opposite of that. Basically, if GetBytes returns destination.length and chars consumed is less than source.length, you have to call it again.
Yep. The pointer-based ones are very inefficient. They actually end up allocating arrays and calling the array overloads.
No, that's the base.
That's the base.
All the overrides then go the other direction. That's because
those pointer ones were added later. They had the exact same problem that the new methods on stream and TextWriter have.
One thing we know very well is how we introduce inefficient API.
Yeah,
we are so good at it.
Yeah, I think I like the transformation status better than mirroring the current behavior.
Right. You're not going to be able. Would you expand it to have more error cases now because it's going to have more errors coming potential, or would you just throw stuff with this?
Well, I mean, we would still have success, destination too small, invalid input, and then if we need some sort of like, I don't think I'm done yet, like for base 64, if we don't have a full mod 4 input, then hey, where's the rest of my data? And I think all of those apply to encoding as well. Your data makes no sense. You haven't given, or I think we got cut off. I ran out of space to write, and we seem to be done. Those 4 seem to. Alternatively, the people who are comfortable calling the pointer ones now, the encoding pointer-based GetBytes, they obviously understand, or think they understand what they're doing. So adding the span versions to give them better length bounds than needing to manage them in parallel is a little better.
I think that's something we need to review here at some point. Like, I mean, I just wrote it up based on what we said earlier, but it may not hold up. But I think we need to basically have that written up somewhere and like agreed upon, because otherwise you will have this discussion on every single fucking type.
Yep.
So my gut feel generally is, and I think that's maybe something that is similar to how Wes thinks about this. So we could make the stance and say, okay, we generally try to match existing types, because the idea is if you're really going after high performance stuff, you probably would use the new APIs that are in corefx lab anyway. So the value that adding spam-based overloads have to existing types is less about getting all performance benefits. It's more about shit. I already had it done in part of my app, so I now have a span in my hand. There's another part of my app that hasn't been spanified yet, so I have to call into existing APIs. And so if I don't have an overload, now I have to do a whole bunch of gymnastics to create a byte array or something and then copy the data manually. And like whatever the other type can do is probably better than what I could do, plus is less work on my side. That still probably doesn't mean that I get the best possible performance out of it, though. And that also goes back to things like here when we say, the existing one throws, so this one still keeps throwing. Well, then, exceptions are not great for performance if that's a major concern.
Okay, so but what about the other GetBytes? So because the problem with like convert from base 64 is there was never a scenario where you gave it too small of a destination because it produced the destination array. So it always gave you one that was the correct size. But now, because there's the overload here we're not talking about, which is the get chars, which returns byte array. It asks how big it needs to be. It fills it using the pointer method, and then it returns it to you. So now we've introduced an error condition, but by changing the method to try get bytes, that sounds to a person who's already used to calling get bytes that we are removing the normal error case, which would be invalid data. But what we're really doing is we've introduced a new error case, and then we're removing that error case. And so I think the problem is if we move to this, we're overloading try in a way that I think will confuse callers. So which is where if we're just introducing a new prefix for I used to return you an array that was the right size, and now you have to give me a buffer.
No, that's
We
why
need a thing other than
I agree with you, but that's why I think the overload as it's written here is in my opinion, incorrect. So we either go with one that is aligned with the transform pattern, in which case it wouldn't be try. It would return transformation status and just be called getBytes.
Mhm.
Or we match the existing overload, which also happens to be called getBytes, and then we would return it in the same way it's there. I think this try, when you have multiple different error cases, is generally a bad idea. I think try is only viable if you have a single span and a single error condition, which is usually buffer too small.
This is the guy we're trying to fix. The one that returns the byte array.
Yes, and that is basically the equivalent is this one here, right?
Right.
Yes. That's what I'm saying. The signature of this thing is, I think, wrong. Either we match the existing pointer-based one, which is also called getBytes, or we go with the transform-based approach, in which case you would call it some either you could still call it probably getBytes or encode or something.
So for now, why don't we just go with match basically exactly or as close as possible what's there, which would basically be int getBytes, read-only span chars, span bytes, close paren. And if we want to subsequently add the transform thing, we can add an entirely new API that's exactly what we want it to be if we find that it's necessary.
So basically, you're proposing to even leave out the chars consume. So
yes,
yeah, I'm fine with that too.
So then to rewind to where we previously used transform status, does that mean we just don't do from base 64 string or from base 64 chars? Because it didn't have an overload that you got to pass it a pre-allocated buffer.
Let me actually go back to that. Yeah, I think for base 64, given that it was so close, Krista proposed that we could almost merge base 64, like the corefx type, with convert. In which was the point would become moot because the new one is effectively the low-level high performance, right? Versus this one is more about, this is not the high performance encoding API, right?
It's fair. I'm just like, because if we bring down transformation status, if we already had transformation status, then I don't know if we would probably here say, oh, well, clearly there should just be a transform.
Yeah, that's why I think it would be helpful for us if we would first agree on that principle and then see whether we can actually apply it in all cases. I mean, as I said, my gut feel is that I think if you have static upper methods like base 64 or the convert class, I think it's almost possible to say the span-based versions are the high-performance ones. But when you talk about things like encoding, where you effectively have a class hierarchy with virtual methods or text reader, text writer, that sort of thing, the problem is you never get to the high-performance thing anyway. So then the question is, okay, if we don't get there, what do we think is more important? Like match the high-performant API shape, or just have it so that if you happen to have a span in your hand, that you can still call these APIs meaningfully, and then deal with sane error conditions. Because I think the problem is also if you go with transformation status, it's possible that we can never return to you transformation status invalid data because the way the APIs are structured, they always end up throwing anyway. And then we would have to, we could probably catch and then just return that enum, but that may not be the right approach either. But yeah, I'm somewhat undecided. But I think that's what we should, that's why I just wrote this down, and then let's just look over the remaining APIs in the last 7 minutes that we have. Hopefully we can actually finish this. Oh no, what was I thinking? There's way more stuff. Let's at least try to finish the numeric.
I like your optimism, though.
Yeah, I know. But the remaining stuff is just networking, so I think maybe that's sensible topic on its own. So numerics.
So this is basically the same as the other primitive types we talked about. It's just not a primitive. So it takes the big integer currently has a byte array constructor. We would have one that takes a read-only span. It provides a method for getting out the bytes, representation of what it contains. So we would want to provide a span-based one. I think we would, based on our previous discussion, this would be try write bytes, and it would probably need to take an out. It would need to take an out int bytes written as well. unlike GUID and the various primitives, there is no size of big integer to determine how many bytes it contains. And then parse and try parse, and I don't remember if there's a big integer parse exact that we would need to go add again, but I guess based on our previous discussions, it would need that too.
We would need to have to expose either the full size of the big integer, if that's not already there. So you could, or you have to have this right method be iterable, like we can iterate 12 multiple
Well, my first question is like just the constructor. What happens if the read-only span at Python is too small? It just blows up as invalid big integer.
That's the input. So
Yeah,
you're
I believe it throws.
Sure, but it could still be too small as in like it's only about an integer, right? I don't know how big integer looks like. I guess it's.
Big integer should be able to take anything.
Yeah.
Convert it to a number.
In fact, if you give it, oh wait, that's
empty
on the way
range
out.
is 0.
On the way out, if we have no bits, then we return the new byte array of 0.
I guess it's okay. So in that case, it's never blows up.
But I'm looking at 2 byte array, not the byte constructor.
So where you said try copy 2 would be try write bytes, right?
And based on what we've previously talked about, I think it would be bool try write bytes, read only or span byte destination comma out int bytes written.
Sorry, it would be bool try write bytes span bytes destination out int bytes written.
I believe so.
Yeah, that's not going to be enough. Like if you didn't give it a span enough, and you hit the number of bytes you wrote, then how do you continue writing?
You start over. I mean, the theory is in a case like these like what we previously talked about with the primitives is it's such a short operation in general that you just start from the beginning. Now maybe big integer is maybe it's more expensive, so that doesn't hold, but I don't even know with big integer whether you can. So go ahead, Jeremy.
It's either 0 or it's exactly long enough to return true.
I think that we could take the calculation it's doing right now into byte array and factor that out to a method, because given the current value, it will always have a fixed size, and we can just expose the method of get byte count. Because even if we do the part where we then come back and say, man, it really sucks that big integer is little endian, instead of like lets you specify your encoding, that the byte count wouldn't change between endianness.
You're saying add a byte count method so you know how to size your span in advance.
Yeah. Otherwise, because somebody else could call it by doing a log base 2 and add 1, but that's ugly. So we could just add the get byte count.
Yeah, it would be kind of annoying to basically have to call this method twice and then take the bytes written and try to compute a value based on the size of the span you passed in and then recompute the size.
But yeah, Christoph seems to believe that the general approach of people is just like, oh, it said I wasn't big enough. Go, hey, buffer pool. I need a buffer twice as big as the one I have right now. And I don't necessarily agree with that, but that's what.
Well, it depends on what it is. So I think for things like this, where you could know the size, it makes sense to give you an API to do that, right? I mean, like, there's no point in growing things if you already know that. I mean, his general argument with growing is that growing is something that happens very rarely, right? Because I mean, if you write data, like say in the networking, and you have a 4K buffer, so how many cases do you actually run into when the buffer is too small? So when it actually finally happens, well, then the cost of that is not too bad. If you have to do a massive dance because it takes you 3 or 4 iterations where you have to correctly size buffer, then you're not only wasting memory, you're also wasting time. But I think in cases like this where you could actually ask for the correct size.
Yeah, so I think every big integer value has one and only one. How big am I going to be when I get written down? So we should just expose the count up here.
Right. It's funny that we never.
Seems fine.
If we did it, I don't see it, but we definitely don't call that helper function inside to byte array. It calculates it and does a bunch of +1s.
I think it's called 2-byte array, don't they?
Yeah, I think that's how you determine how long it'll be.
Okay, so we should expose a property or method. I guess a method.
Probably.
That
Could be a property. It's a one-shot, but
the size
Good. And then I think parts and triparts were fine, correct? Modulo, the typical.
Yeah, we'll just double check that they actually match the signatures that big integer currently exposes. And
I also have too many commas.
Yeah, that one comment is just not going to compile.
Whatever. Things that don't compile are not our problem.
That's why we have compiled. All right, then it seems fine. Alrighty, this was a long meeting, so it seems like we have another 2 hours in front of us to go over the networking-based APIs.
Yeah. IP address will probably also need the count because we don't know if we're, unless we already exposed V4 or V6.
no, but I mean that's. Do we really? Okay, I don't know. I kind of buy it for big integer because you could have arbitrarily long things, but for IP address, I mean, we're talking about like what 16 bytes or 32 bytes or.
Well, you're either 4 bytes or you're 16 bytes.
Sorry, bits I meant. Yeah, but yeah.
Those are the two valid of the current values of IP address. It's either 4 or 16 bytes.
Yeah.
Does this support both? Do you know?
Yes.
Yes.
It supports 4 and 16, which is IPv4 and IPv6.
Yeah, I mean, I'm fine with returning for like having.
Fair enough. I mean, like somebody who wants to write it down, they can either guess or just allocate the bigger one and make sure that they could have held a V6.
Do we expose it there? It's IPv4 versus IPv6.
I don't know.
Because if we do, then you could also just ask that.
Yeah, it shares what family it is.
Oh, then you can know ahead of time. Then it's fine. If people complain that they need too much domain knowledge, we can add API later.
Yeah. Again, though, like this is an example where Christos, I think, holds up, which is like how many times do you run out of space for that?
Well, it's not running out of space because you're encoding an IP address. It's you're running out of space because you're encoding an IP address here. And then, go copy the whole, but like.
No, true, but I mean, how many cases do you allocate a span specifically just hold a single IP address? Like that's super rare. Like
Right.
Never occurs. You would probably encode it into an existing buffer that holds much more data anyway.
Right.
In which case, you only care after the fact that you know how many bytes you have written so you can advance the pointer correctly.
Yeah.
And then the question is, okay, how many places would you actually have to resize?
Indeed, and when you call it again with like, I need a buffer from the pool that's like 3 bytes bigger, it's like, you know what, here's one that's a K bigger, shut up.
Exactly, that's what you normally do in this case, so that's why the size doesn't matter.
Fair enough.
Okay, we have sockets, WebSocket, HTTP, crypto.
Yeah, crypto.
Other namespaces, so I think it's probably going to be a solid another, either at least an hour, if not 2 hours.
Steve, is there anything as bad as iCrypto transform?
Nope.
Okay.
That's pretty much the worst.
All right.
I don't think we've talked about any cases where interfaces are not what we want. So that'll be the first.
Okay.
All right, then let me suspend this one, and then there's another 2 hours waiting for us. I will set up another meeting.
Thank you all.
Thank you.
Thanks, Steve.